Today we're going to talk about rational exponents and radicals. Okay, first things first, right? A couple of vocabulary words. So the index is the number that's going to be on the outside of the sign. That's called an index, okay? This sign is called a radical sign. We've used it as a square root sign, but it's really a radical sign because there's more numbers than a square root. There's a cube root, there's 4, there's 5. You can put any number as that index. And then the number underneath the radical sign is called the radicand. All right. So first things first is relatively easy, right? So there's buttons on your calculator that I'm going to show you as well. So what we should recognize is if I were to just simply ask you to give a sidebar like the square root, let's say, of 36, what would you say the answer is? Go. 6. Because what's missing, what this means is what number times itself is 36, right? And so what we assume here is that's it. There's a hidden index on these that they don't put in, and it's a 2. All right? So what this means is, what is the cube root of 125? It means what number times itself again is 125. It's not 125 divided by 3. The number has to be the same number times itself again equals 125. Malcolm, what is it? It's 5. Yes. So the answer to this is 5. And this is your because 5 times 5 times 5 is 125. But the answer is just 1 5. Okay? So what would be the fourth root of 16? David, what is it? It's 2. And the reason is because 2 times 2 times 2 times 2 again is 16. That's how you do this. All right. Now, let me show you, because down here there's a got it, right? These ones are relatively easy, but look at got it part B specifically. This says, if you can't see it on the video, it says what is the fifth root of 32? And that one is not as easy to just come up with in your mind. So in your calculator, okay, if you turn it on, oh, my batteries are low. The root key, right? There's a square root that's on here above the x squared right here, but that's not what we use. If you press math, there's a cube root on there if it's a 3, but if you want any number, see the fifth one down that says x as the index here? If you scroll down or just hit number 5, press enter, some of you will get, sorry, I must not have cleared my answer. Some of you, depending on how new your calculator is, will get like a little sign there. So does someone have a newer calculator I can show? Who has the newer one where it just came up? Yeah, let me see that, David. All right, so mine's an older calculator. I actually want to show you on the newer calculator. So it says answer. So what you really need to do is put the index in first, okay? So this is what mine says. This is new versus old. So I'm going to clear this out real quick. Sorry. So let's say we want the fifth root. So we're going to press 5 and we'll press math. And then we're going to put in the x. So that 5 on the newer calculators will come in as the index right here. On the older ones, looks like this. And then you put in your radicands, which is 32 in this case. And then you want to arrow out of it so that it's not showing an arrow. And then press enter and it will give you the answer. Or if you don't have a calculator, right, a graphing calculator specifically, this function is not on just a standard calculator. You have to have a graphing calculator to get it. But the idea is then you would have to guess and check what number times itself 5 times would give you 32, and the answer is 2. Okay, so far so good. That's the basics. All right, now, guess what? We're going to put fractions in them.
No!
It's going to be so joyful. Ready? Yay! Okay, so here's the key concept. All right? Which I just copied for you. But basically, the idea is that a radical with a fraction on it is really equal to like an exponent that is a fraction, okay? So the idea is if you have a base A, any number, and then you have a fraction, m over n, they say, what that means is that the index is the denominator, and then the numerator is actually the exponent on your radicand, okay? So what I want to show you is the example. It's a little bit easier. So just write this down if you haven't already. The denominator is the root or the index, okay? Okay. The numerator is the exponent, and that is on the radicand. Radicand. Okay, so what this means is if you have 8 to the 2/3 power, for example, the 3 is your root or your index, right? That goes outside of the radical sign. The 2 is the exponent really on the 8. So this is what it really is as a square root, okay? Or as a root. I can't say square root. And then, so if I do this first, 8 squared is 64, right? And then the third root of 64 is 4. That's how we simplify it. Okay, let's practice, okay? This takes some practice because two things. They're not all numbers. Clearly, the first example has a letter on it. All right, they're going to throw letters in there because that's fun. And they're going to throw parentheses in there too. Let me show you. All right, so notice on the first one, no parentheses. The 2/3 is only on the A. It's not on the 12. Okay, so when we are asking to convert to radical form, we're going to leave the 12 alone, right? And then what we're going to do is we're going to move this around so it's like this. So we're going to put our radical sign. And what's going to be our index or our root on the outside? The 2 or the 3? The 3, yep. And then A is going to be underneath here. That's our radicand. And what's going to be the exponent on the A? 2. Now, technically, there's a time sign in between there, but you don't actually even have to write it. That's radical form. That's it. That's the answer. Okay? Now, what's the difference? Right here, there's a parenthesis, okay? And so what we learned before this, which has been a while because we've been doing other things like testing, okay? But that means that this 4/5 goes with the 64 and the A, right? It gets distributed to both. So this is really 64 to the 4/5 times A to the 4/5. And if we have to put that in radical form, we start by doing the 64 to the 4/5, okay? So we're going to do this. We're going to make a radical sign. What goes on the outside, the 4 or the 5? The 5. 64 is going to be underneath there. And then the 4, the numerator, is going to go as the exponent. We're going to do the same thing. Now there's a time sign. We're going to do the same thing with the A. So we're going to put the 5 on the outside, the A underneath, and the 4 under here. Now, when you have it like this part with the A, you can't simplify that, but you can simplify this because it's all numbers, okay? So this is how we do it. 64 to the 4th power underneath here. Now we're going to do this out. Your calculator will do it, but all right. Oh, sorry. My calculator is telling me my batteries are low. All right, 64 to the 4th power is really this number right here. Wow, we are really glitching today, aren't we? All right, so there it is. So we really have the 5th root of 16777 right? Now, how do I put 5th root in my calculator again? What do I press? Who can tell me what I press? Go ahead, Carla. Math? Oh, hold on a second. Before we do math, we got to do something else. Start with 5, then math. Then do your 5 here. Yep. because you got to start with the index and then type this number underneath that. And I'm going to cheat and I'm going to put second and then the negative sign. What do you think ANS means? Answer. It means that last answer I had. So I don't have to type it in. See how it says ANS over your negative sign down here? And it's above it. So if you ever don't want to type the answer, the last answer you put in, you could put second that. All right, and then press enter. And this one is a decimal. Okay? So sometimes this is going to give us a decimal. All right? And so what we do is we either use the decimal or we leave it like this, right? And then we put a to the fourth on it. Does that make sense? Since we got a decimal there. All right. The reason why I can do that is because this right here and this right here is for both of it, right? There's a fifth root for both of them. This part can be simplified. This part, we don't know what A is, so you have to leave it. Does that make sense? Okay, good. Let's try down here. Let's just do B and C, which for some reason we got crossed out here. All right, let's try B. So B, 5x to the 1/3. Let's put it in radical form. Go ahead and try it on your paper and then see if you get what you're supposed to and what I get. Does anyone have it? Go ahead, Malcolm. What'd you get?
5 times sign.
Radical sign. Okay.
3
on the inside or the outside?
outside.
Okay.
X 1.
And there's technically a 1. Can I leave it at x?
Yes.
This is the answer. So this is 5 times the cube root of x is the final answer. Great job. All right. There's technically a 1 on here. Would I mark it right or wrong if you put the 1? Right. What one's going to be on your SAT? Without the 1. Okay. All right. Now let's do the next one. Okay. So what's the first move that needs to happen on the next one? What happens, David? Distribute. So this is really 54 to the 2/3 and then y to the 2/3 and then their times, okay? Okay, so let's write it with the radical, okay? What number goes on the outside of both of those radicals? The 3, yep. And the 2 is going to be our exponent. All right, 54 goes here and y goes here. All right, which part can I simplify? 54, right? 54 squared. If we do that in our calculator, we get 2,916, right? So I really have the cube root of 2,916 here. Now, let's see if that simplifies or not. Okay, so, oops, sorry. All right, does this simplify? How do I check it? What do I type in my calculator? Go ahead, Malcolm. 3. Math. 5. Perfect. Did that simplify or no? No. Nope. So then what do I do with this guy right here? The whole thing or just what? Okay, put y2 underneath. There we go. Whoa, look at those synapses going off in these brains today. All right, one last thing. Flip. Okay, what if they ask you to go the other way? So I just taught you how to put exponential form into radical form. What if they give you exponential and they want you to go back into radical and go back into exponential. For example, what is the fifth root of b to the third in exponential form? What do you think the answer is? Now, we're going to get rid of the radical. Malcolm, you're on fire today. Go. As the exponent.
Yes.
You just take whatever your index is, which is the 5, and you put it as the denominator, and whatever your exponent is on there, this is the answer. It cannot be simplified because b is a variable. We don't know what it is. All right. Okay, where it gets a little more challenging now is if there is a number in there. Okay, so let's think about this one for a second. Okay. Barwani, you get a chance here. Go.
Parentheses 27D, the other parentheses 3/5.
Close. All right, David.
It's 5/3.
It is 5/3. All right. 5/3. Okay, now let's think about this for 1 second here. Okay, so 27's been simplified. You got it. So like on the one before, we simplified that first one, right? So I agree with d to the 5/3 right here. Okay, but what we have here, right, is that this 27 couldn't have been simplified anymore, right? As what ended up happening. All right. So what was that going to end up being? 3. Because we had to cube it. Yeah. Okay. That's it for the lesson. All right, for today. So we are going to work on something that looks weird. This is actually out of our book that only I have. So there's that. So here's a copy. And and I know it starts at 11 here, and it only goes to 34, okay? So it goes to 48, but we're only going to go to 34 because that's what's going to be on our test, okay? We're not going to worry about all this other stuff.